Assalamu alaikum and welcome to my YouTube channel process simulation. Today in this video we will see the impact of adding a miscellaneous atom in the pipe sim. Miscellaneous atom can be anything: control valve or heat exchanger. So let's go and make a very simple simulation that will have the source and the sink. First I will make a normal simulation with source and sink. We will check the pressures and then we will add a miscellaneous atom to see the impact or see the catch. What's the catch in the pipe sim? How to make sure that you are putting a correct value so that you will get the correct results. So for that purpose, first we will go to fluid manager to specify the fluid, and then we definitely will go with the black oil model. Just bear with me for the software lagging. So we will click on add and we will select the none template. So I will keep this simple. I will keep the 0 GOR. I will keep some water cut, let's say 35 water cut. For the API cavity, I think let's go with the 35 also. So by clicking close, our fluid is now specified, and now we have to map it. We will go to the source to map it. Okay, for this simulation we will be putting the pressure at the sink as a 10 bar gauge, and we will see what the back pressure we are getting. So for the mass flow rate, let's put some 12,000 barrels per day. So this is just a random example. We will run it and see, and if we get a good pressure drop, okay, if not, we will change the either flow rate or we will decrease the line size. So sink, as I said, and I will put in 10 bar gauge. So for the pipe size, I think we will go with the 8-inch. Let's wait for the software to open the dial box. The software is lagging too much today. Yeah. Okay, in the nominal diameter column we will go and put 8-inch, and let's search the 40 schedule 8-inch pipe. Yes, here it is 16, I guess, raw number. Okay, for the length now, I am just putting around 1.5 kilometers, so it will be 1500 meters. To run the simulation to see what's the back pressure we are getting at the source. So let's convert the pressure into bar gauge. Oh, we are getting hardly 0.5 or less than 0.5 back pressure. So it means that we have to change something. Okay, let's go and change the mass flow rates, liquid flow rates. So we put 12,000. Let's make it 62,000 and see what's the impact. We will go and run the simulation. So now after running the simulation, let's go to bar gauge, PSI gauge, bar gauge. Yeah, we are getting around 18 bar, so that's good. We are getting around 8 to 9 bar pressure drop. That's good. So now we will go and add a miscellaneous atom near the source. Miscellaneous atom is added as a generic equipment. So problem is that here we are at the generic equipment. I'm just putting a connector. Huh? So now if you remember, we put 10 bar gauge at sink, correct? And let's put the let's first put the pressure drop as 5 bar. So you remember we put 10 bar gauge and we get the source pressure as 18 point something, no? So now we are adding a 5 bar pressure drop. So let's see, the source should be increased to somewhere 22 or 23 bar gauge. Let's see what's the Pipesim give us the results. So if you see here, instead of increasing the pressure, it decreases the pressure at source. So it means that it's taking generic equipment as something that is adding 5 bar, not a pressure drop. So that's why in Pipesim we have to make sure that if we adding any generic equipment, we have to put the pressure in negative. So then only it will act as a pressure drop. Otherwise it will take as a pressure gain. So we will go and put a negative there. So now we will run the simulation. So now we will go and change it to bar gauge. So as you see, now we are getting 23 bar gauge. So this is the catch in the Pipesim. So whenever I'm using a generic equipment to add as a heat exchanger or anything, we have to make sure that we are putting the pressure as negative, and then only we will get the correct pressures. That's all for the video. Thank you, and we will see you in the next video.